All right, section. Hold on, what is the section again? So many. 15.3, running code on cleanup with the drop trait. Let's get it. The second trait important to the smart pointer pattern is drop, which lets you customize what happens when a value is about to go out of scope. You can provide an implementation for the drop trait on any type, and the code you specify can be used to release resources like files or network connections. We're using drop in the context of smart pointers because the functionality of the drop trait is almost always used when implementing a smart pointer. For example, box customizes drop to deallocate the space on the heap that the box points to. Alright, so what they're saying here is that this section is going to be going over drop, the drop trait, and the drop pattern. And the reason they're tying into smart pointers is because almost all smart pointers have to implement drop. And they gave an example with box. Continue onward. In some languages, the programmer must call code to free memory or resources every time they finish using an instance of a smart pointer. If they forget, the system might become overloaded and crash. In Rust, you can specify that a particular bit of code be run whenever a value goes out of scope, and the compiler will insert this code automatically. As a result, you don't need to be careful about placing cleanup code everywhere in a program that an instance of a particular type is finished with. You still won't leak resources. So what they're emphasizing here is that in some languages, when you have to do cleanup code, you have to specify it each and every time you try to clean up a resources. However, with Rust, seemingly you write the drop, you implement the drop trait, and then the compiler will automatically insert that code when needed. So you don't have to worry about putting your cleanup code everywhere, because if you did it once, you did it every time. Specify the code to run when a value goes out of scope by implementing the drop trait. The drop trait requires you to implement one method named drop that takes a mutable reference to self. To see when Rust calls drop, let's implement drop with printline statements for now. And they're going to have a code example here. Let me read this real quick. Listing 15-14 shows a custom smart pointer struct whose only custom functionality is that it will print dropping customer smart pointer when the instance goes out of scope. This example demonstrates when Rust runs the drop function. Alright, so it looks like we're going to implement the drop trait on this struct just to see when it goes out of scope. And that looks like it can be written, so let's open the editor. Let's get it. So what they have here is a struct custom smart pointer takes in data that is a string and then here we implement drop for custom smart pointer, and in our function drop, like they said, it takes a mutable reference to self, and we're just gonna have a print line here. Dropping custom smart pointer with data. Explanation point, right? And very important, they have self dot data. It's hard to see it, but yeah. Bam. And now we have our main function. Let's see equal custom smart pointer. We have our data, which is string from, and this is my stuff. let D equal custom smart pointer data string from, and this is other stuff, right? And now we have a print line. Custom smart pointers created, period. And let's run this to see if everything is working properly. Don't know what that is. Cargo run. It looks like it is. We got warnings because we didn't actually actively use C and D. But here we see that the custom smart pointer is created, this line. And then after scope ended, the drop trait was called, or the drop function. And this is seemingly in reverse order. We have my stuff, other stuff. Here we have other stuff first, my stuff. Okay. The drop trait is included in the prelude, so we don't need to bring it into scope. We implement the drop trait on custom smart pointer and provide an implementation for the drop method that calls println. The body of the drop function is where you place any logic that you want to run when an instance of your type goes out of scope. We're printing some text here to demonstrate when Rust will call drop. Alright, so what they're seemingly saying here is that, one, when we have a variable and it goes out of scope, we know that it's going to be deallocated, and that the drop trait is going to call the drop function. Well, the drop function is going to run. If you ever want code to run, like you explicitly have, let's say, cleanup code, and you want it to run right before your memory gets deallocated, then you will put it, all that code you want to run in the drop function by implementing the drop trait, just like we did here. We did it with just a print line, so you can just see it visually, but you can write anything you want there, seemingly. In main, we create two instances of custom smart pointer and then print custom smart pointer created at the end of main. Our instances of custom smart pointer will go out of scope, and Rust will call the code we put in the drop method, printing our final message. Note that we didn't need to call drop method explicitly. When we run this program, you'll see the following output. And this is what we did see, it's down here. Rust automatically called drop for us when our instances went out of scope, calling the code we specified. Variables are dropped in the reverse order of their creation. So D was dropped before C. This example gives you a visual guide to how the drop method works. Usually, you would specify the cleanup code that your type needs to run rather than a print message. So basically what they're stating here is that this is just a visual guide because we get to see when the drop method was called because we did a print line. But important is here. It seems that everything is dropped in reverse order. So D was dropped before C. And D is the other stuff. And then C is the my stuff. So you can see that it was actually really in reverse order. Dropping a value early with system memory drop. Unfortunately, it's not straightforward to disable the automatic drop functionality. Disabling drop isn't usually necessary. The whole point of drop trait is that it's taken care of automatically. Occasionally, however, you might want to clean up a value early. One example is when using smart pointers that manage locks. You might want to force the drop method that releases the lock to run so other code in the same scope can acquire the lock. Rust doesn't let you call the drop trait's drop method manually. Instead, you have to call the system memory drop function provided by the standard library if you want to force a value to be dropped before the end of its scope. Alright, so what they're stating here is that there are times where we want to call drop or have our variable deallocated, freed from memory, prior to it hitting the end of scope. And if you want to do that, well, you can't call drop directly, at least the drop method. However, they seem to have another function for it. System memory drop. They gave an example of a scenario where you would want to do this, but most likely in most cases, this is not something you should be doing. If we try to call the drop traits drop method manually by modifying the main function from listing 15-14 as shown in listing 15-15, we'll get a compile error. Let's just mimic that real quick. They got rid of D. They left that sentence and they did C dot drop. Oh, I have a semicolon there. And then they did print line custom smart pointer dropped before the end of main. I see what they did here. Yeah, so they're going to try to explicitly drop it before the end of scope, and they have this print line that should print to denote visually that the scope hasn't ended yet. But we have this red squiggly line. Does it say something? And it gives us a hint if I hover over it that says replace with system memory drop. So even the editor knows that this is not going to work. And let's see how bad it is. Explicit use of destructor method. And it says explicit destructor calls not allowed. No help. Alright, no help message. Hint. No hints, I should say. Okay. Okay. When we try to compile this code, we get this error, which is the one we just saw. This error message states that we're not allowed to explicitly call drop. The error message uses the term Destructor, which is a general programming term for a function that cleans up an instance. A destructor is analogous to a constructor, which creates an instance. The drop function in Rust is one particular destructor. Rust doesn't let us call drop explicitly because Rust would still automatically call drop on the value at the end of main. This would be a double free error because Rust would be trying to clean up the same value twice. I see. So here they state why this is not allowed. You can't explicitly call drop like this because if you did, C will still be in scope. And because C is still in scope, once it hits the end of scope, Rust will automatically try to drop it again. And in that scenario, then you will have two drops, which would mean you try to clean up the same memory twice, which is the double free error that they mention here. We can't disable the automatic insertion of drop when a value goes out of scope, and we can't call the drop method explicitly. So if we need to force a value to be cleaned up early, we can use the system memory drop function. The system memory drop function is different from the drop method in the drop trait. We call it by passing the value we want to force to be dropped early as an argument. The function is in the prelude, so we can modify main listing 15-15 to call the drop function as shown in listing 15-16. And it looks like all they did was drop C. I see, and then drop takes ownership of C, and then it gets dropped at the end of drop scope. Makes sense. Let's run this to make sure it works. Bam. Smart pointer is created. This line, dropping the custom smart pointer with data my stuff here being dropped. And then the last line, which shows that scope hasn't ended yet, we have the print statement. Custom smart pointer drop before the end of main. Okay. And they have the output right here. The text dropping custom smart pointer with data, some data, is printed between the custom smart pointer created and custom smart pointer drop before the end of main text, showing that the drop method code is called to drop C at that point. The only difference we have between the two is I forgot to change this, so I have my stuff, they have some data, and I think I forgot a period. No period here. Anyway, you can use code specified in a drop trait implementation in many ways to make cleanup convenient and safe. For instance, you could use it to create your own memory allocator. With the drop trait and Rust ownership system, you don't have to remember to clean up because Rust does it automatically. You also don't have to worry about problems resulting from accidentally cleaning up values still in use. The ownership system that makes sure references are always valid also ensures that drop gets called only once when the value is no longer being used. Now that we've examined box and some other characteristics of smart pointers, let's look at a few other smart pointers defined in the standard library. Okay, let's summarize real quick. So in this first paragraph, they're just restating how convenient drop is. You never have to worry about forgetting to write your cleanup code because Rust is going to do it automatically for you using the drop trait. And then if you wanted to write your cleanup code yourself or have something in there that does some extra work, you can implement the drop trait yourself and then do the drop functions, kind of like we did. You wouldn't put a print line there, but you would put something else there. And then here they let us see the other side of the coin, where they say that we never have to worry about Rust deallocating memory early while something is still in use because the ownership system doesn't allow that to happen. So that's another word we don't have to care about. And lastly, they state that we're going to move on to some other smart pointers in the next section. Alright, that concludes this video. I learned something. I hope you guys did as well. If you enjoyed the video, like, subscribe. Outside of that, peace.